The name of topic is LED, light emitting diode, photodiode, and thermistor, subject of the analog electronics. In LED or light emitting diode, so what is the definition of LED and what is the material used for the LED and what is the application of LED and LED configuration and other uh, parameters uh, that the explain the what is the LED and performance of the LED and the different manners. So, what is in LED light emitting diode? Light emitting diode is a simple semiconductor diode which have the two terminal. One is the cathode terminal and second is the anode terminal. Or we see in this uh, diagram the photo or picture of the light emitting diode. So there are two legs. One leg is shorter, that is the cathode or negative terminal, and one leg is longer, and that is the anode or positive terminal. So this is the uh, two terminal semiconductor device. So the it has polarity negative and positive in the form of terminals. So a light emitting diode is essentially a semiconductor that emits a monochromatic signal operate in the forward bias direction, and we know that the diode or LED is operating in the forward bias condition, and in the LED the light is emit uh, the energy is emit in the form of light, so the LED convert electrical energy into light energy. They are frequently used as a pilot light in electronic appliances to indicate whether the circuit is closed or not. So this is the symbol of LED, in which have the two terminals. One is anode and second is cathode. And in LED, there is the working function of LED. We see here in which LED there are basically two types semiconductor material used. One is the P type and second is the N type, and also there a formation of uh, junction. So carrier charge cross the junction from one side to second side. So the due to the flow of charge carrier, the current is generated, and when charge carriers jump from one energy level to second energy level, then the energy release in the form of light. So a negative electrons move one way and positive holes move to the other way, as shown in this diagram. The holes exist at a lower energy level than the free electrons. So therefore, when a free electron fall, it loses energy, and this energy released in the form of light. So in this LED, energy is emitted in a form of a photon which cause the light. So color of the light is determined by the fall of the electrons and hence energy level of the photons. We see in this picture, so this is the uh, cutting section of the light emitting diode. Inside a light emitting diode, emitted light beams and a diode and transparent plastic case to the outside of this diode, and there are total two terminals pins, which is one is anode and second one is the cathode. So it have mostly three parts. One is the transparent plastic case, second one is the terminal pins, and third one is the diode. So that is the cutting section of the LED. In testing of LED, never connect an LED directly to the battery or power supply, and it will be destroyed almost instantly because too much current will pass through and one LED. So due to this, we cannot connect an LED direct to the battery or power supply because too much current will be passed through and LED will be burned. So we have a resistor in series to limit the current to a safe value. For quick testing purpose of a 1 kilo ohm resistor is suitable for most LED if your supply voltage is 12 volt or less. So we draw the uh, testing circuit diagram. In this circuit diagram, there is a 1 kilo ohm resistor is connected with the series of the light emitting diode and 9 volt supply applied to the LED, and with the help of this 1 kilo ohm resistance. So we see in this circuit diagram the supply voltage is not directly applied or not directly connect to the LED, and this is applied or connect by the with the 1 kilo ohm resistor. So this is the testing of LED. So remember to connect the LED the correct way round. There are different kinds of LED. There are in color red, green, white, and yellow, and others maybe in other colors. Some types of LEDs. There are some LED which show the different picture of the different type LED, and also here a 7 segment LED which is used generally in digital watch, and other LED which is generally used in electronic home appliances. So there are some types of light emitting diode pictures and photo. And what is the application of LED? So there are many applications, and the such as sensor application, mobile application, sign application, automatic use, and LED as a signal application and illumination and indicators. So these are the some applications of the light emitting diode. So there is the one application as a sensor application of the light emitting diode. This is the picture of the sensor, and also the application of LED in mobile application. So we use the light in mobile as a help with the LED. Some application of green LED. So in this photo different type of LED, green traffic signals are one of the unique application of the green LEDs, and the high brightness LED for outdoor applications. So these are the also applications of the LED in the traffic light signals. Now, what is the material of LED? So it must have an energy gap appropriate width. So both p-type and n-type must exist the uh, resistivities, and the efficient radiative path must be present. So gallium arsenic, gallium phosphorus, and other materials, alloy materials are used in the light emitting diode. So this is the some materials, semiconductor materials which are used to made the LED. There in this slide, there is the comparison between the luminous efficiency uh, versus time and technology. Luminous efficiency of LED to attain by the 2015 is based on the expectation that LED will be able to attain 50% to 70% of the theoretical and maximum the theoretical maximum of the luminous efficiency is 300 luminous per watt. So there is the comparison efficiency of different luminous efficiency versus time and technology. There are some advantage of LED. So LEDs save up to 90% energy and no warm up and 100% brightness immediately and last up to 3 times longer than the uh, bulbs. So fit into any standard lamp socket easily. Maximum bulb temperature is 55 degree centigrade and non-toxic, no pollution, and full dimmable, no IR and UV radiation in this the LED. So warm white light color and viewing angle of 240 degree. But there are some disadvantage of LED. So LED is the consume more energy and relatively costlier. So that is the advantage of LED. Next semiconductor device is the photodiode. So in photodiode, what is photodiode and what is the theory of photodiode, and we discuss about the feature of photodiode and what is material is used and types of photodiode, photodiode construction, and VI characteristics of photodiode, and what is the application and what is the advantage and disadvantage. So there are some points uh, there are of photodiode, and we discuss one by one to these points of photodiode. So what is the photodiode? So a photodiode is a semiconductor device that convert light into current. So this is the photodiode function, and the we see in this in these photographs there are different shape and different size. Some photodiode pictures here, and we can see in this uh, slide of different photodiode shapes. So Photodiode technology developed since 1940. Photodiode technology was refined in 1950. Silicon has been the favored material for photodiode. So germanium silicon can also be used, and it is used was first in 1962 by the REACH. So in photodiode technology, and the photodiode technology is used the material for the made of photodiode, germanium and silicon. So these are the two mostly semiconductor materials which is generally used to make the photodiode. So excellent linearity with respect to incident light. So second feature of the photodiode, low noise and wide spectral response, mechanically rushed, and next one is compact and lightweight. And next is the long life. So there are some features of the photodiode. That is the construction of photodiode, and here the cross section of the silicon photodiode. So in the construction of photodiode, we take the P active area and a deposit on this P active area a diffusion mask of the SiO2, and we a, mm, have the terminal of this P active area a anode, and the silicon nitrate passivation AR coating on the area of the anode, and the P-type, that is the P-type area, and second one is the N-type area, that is the bulk area. So here between anode and cathode, or P-type area or N-type area, there is a formation of PN junction, and between the PN junction, a depletion region is formed. In depletion region, there is a immobile charge carrier across the junction. So width of the depletion layer is very small in the size, in the range of Armstrongs. So back metallization is called the cathode, and here the back contact diffusion layer, and upper the this back contact diffusion layer is the heavily doped N plus type semiconductor. So this is so the photodiode construction in which different layers and different area of p-type semiconductor and type semiconductor, and some layers of diffusion mass as SiO2 and a silicon nitrate passivation AR coating. So this is the photodiode construction cross section of the silicon photodiode. Now in the VI characteristics of photodiode, or graph between the voltage versus current, this show the characteristics of the photodiode. So we take the reverse voltage versus reverse current and draw the characteristics of the photodiode at the different reverse voltage and measure the different value of reverse current. So the shape of the graph, or the variation of the current versus voltage in the photodiode as shown in this graph. So there is a dark current. Dark current is the very minimum or very low current which have the range of the nanoampere or microampere. So this is the uh, uh, graphical representation graph between current versus voltage of the photodiode. And what is the advantage and disadvantage of the photodiode. So there are some advantage and some disadvantage. So first advantage is that photodiode detector are high NIR sensitivity and high speed. So this is the first advantage of the photodiode. Second one is that there is low noise. So this is the very important advantage because low noise and low dark current. Also, this is the third advantage of the photodiode. Low dark current or low reverse saturation current. The current uh, which have the range in the micro ampere to nano ampere. So this is the very low amount of the dark current. And some disadvantage of the photodiode here. So one disadvantage, normal PN junction photodiode have very high response time. So this is the first disadvantage of the photodiode. Second one is the it has very low sensitivity. So this is the second advantage of the photodiode. It has very low sensitivity. And there are some applications of the photodiode. So one application photodiode are used in photo detectors, and second photodiode are used in camera as photo sensor and slotted optical switch in scintillators or etc. So these are the applications of the photodiode used in camera as a photo sensor and slotted optical switches. And next one is the photodiode are used in consumer electronics. So this is the next applications of the photodiode. Next device is the thermistor. And what is the thermistor? So thermistor is a temperature sensing element which measure temperature according to the change in resistance. So the in thermistor, the temperature change according to the change in resistance or resistance depend on the change of temperature. So it is usually made of a sintered semiconductor materials, so they can or cannot be self-heated. So they are ceramic or polymer material, while RTD use pure metals. So we use the ceramic or polymer material to make the thermistor device, and they are available in various shapes like disc, rod, washer, etc. There are different shapes uh, of the thermistor and available in various shapes, just like disc, rod, washers, etc. So there are two diagrams that is represent the thermistor device. The first diagram, this is the representation of thermistor and generally used in the US and Japan countries. But in Europe countries, the second symbol or second diagram represent the thermistor. So these are the two types of representation or two types of thermistor symbol that is represented by the two for in different countries. There are some shapes of thermistors. So there are total four shapes. First is the bead shape, second is the probe shape, and third one is the disc shape, and fourth one is the rod shape. So in bead shape there is two leads, and one is the glass coated beads. So this is the bead shape. But in prop shape there are also two leads and a glass that is covered the bead, and third is the shape and disc. So there is two leads, and one is for uh, in rod form. Second, third, sorry, C type is the disc type, and D type is the shape of rod. So this is the different type of shape of the thermistor device. So there are two positive temperature coefficient thermistors, and second one is the negative temperature coefficient thermistor. So graphical representation of the positive temperature coefficient thermistor, as in graph first, the graph between the resistance versus temperature. This show the positive temperature coefficient of the thermistor. What in the second graph, the graph between the resistance versus temperature, this show the negative temperature coefficient thermistor. So there are graphical representation between resistance versus temperature of the thermistor positive temperature coefficient and negative temperature coefficients. So thermistor is the low cost device, and this sensitivity is very high, and in size it is very small, and good stability and high output signals, and easy to transport. So these are the some advantage of the thermistors. And their non-linear output is seen and not suitable for high temperature measurement. So this is the not suitable for high temperature measurement, and this is the disadvantage of thermistors, and it require external power supplies. So this is the also one disadvantage. And next one is shielded cables should be used to minimize interference. So for minimize interference, here shielded cables should be used. So in next disadvantage is the self heating. So some heating is generated in self. Next, there are generally two types of thermistors, and we divide the thermistor in two types. First one is the PTC. In PTC, current limiting device, that is the current limiting device, and timer in decoursing coils, and motors and self-regulating heaters. So this is the some parts of the PTC thermistors: current limiting device, timer and degaussing coil, motors, self-regulating heaters. What in NTC second type thermistor, there is very low temperature thermometers. It has very low temperature thermometers. Second is digital thermostat, and next one in rust protection devices. So next one is the battery pack monitors. So these are the two types of thermistor: PTC thermistor and NTC thermistors. So these are the some uh, explanation about the thermistors and photodiode and light emitting diode. So these are the uh, semiconductor devices, and the concept of these devices generally the semiconductor materials which is used in to made these devices which have the uh, very important roles of semiconductors material to make the semiconductors devices. So now there are some reference books which covers these topics. Electronics device and circuit by the J.B. Gupta, and second one is the principle of electronics, which is by the Milman and Halkias. There are some multi-choice questions of these topics, so they are very interesting and important question for clear the concept of these topics. So question number first, light emitting diode emit light when it is in option A forward bias, option B reverse bias, option C zero biasing, and option D infinite biasing. So here correct answer is A, option A for the forward biasing, because the LED diode emits a light when LED biasing is forward biasing, or we can say that the light emitting diode conduct in the forward biasing mode. Question second, the nature of light emitted by LED depend upon option A, nature of material used in LED, option B, the difference in energy levels of material used, option C, both A and B, and option D, neither A or neither D. So nature of light emitted by the LED not depend the nature of material used in LED and the difference in energy level. So correct answer is the option C here. Question number third, limiting resistance R is used in LED for. So what is the role of resistance in the LED? So option first A, controlling current flowing through LED. Option B, controlling color of with light. Option C, both A and B. And option C, neither A nor B. So here the correct option is option A, controlling current flowing through the LED. So the use of the resistance in light emitting diode, that is the controlling the current flowing through the LED. So that is the main use of the resistance used in light emitting diode. Question number 4, LED of gallium arsenide and gallium arsenide phosphorus release energy in option A, infrared and visible region respectively. Option B, visible and infrared region respectively. Option C, visible and ultraviolet region respectively. Option D, ultraviolet and infrared region respectively. So here the correct option is A, LED and GaAs and also GaAsP released energy in the uh, infrared and visible region respectively. So this is the correct answer of this question. Question number 5. LED are most popular used because option A, it's operate at high voltage. Option B, its power consumption is less. Option C, it is cheap and easy to handle. And option D, both B and C. So correct answer here is option D. It means its power consumption is less and it is cheap and easy to handle. So LED are mostly popular due to this reason. So correct answer here is option D. Next question number 6. LED are used in option A, visual display. Option B, decorative lamp and photo frames. Option C, both A and B. And option D, neither A or B. So here the correct answer is option C, or LED are used in visual display. Second one is the decorative lamp in photo frame. So here the correct answer is option C. Question number 7. What is full form of LED? So option A, low emitting diode. This is the very important question. Light emitting diode. Option C, light emitting data. And option D, light encounter diode. So here correct option is B. So here correct answer is B, light emitting diode or LED. So full form of the LED is the light emitting diode. Next, question number 8. A light emitting diode is option A, heavily doped. Option B, lightly doped. And option C, intrinsic semiconductors. And option D is Zener diode. So here correct answer is option A, heavily doped, because B, doping the impurity in the light emitting diode. Question number 9. Which of the following is not a characteristics of LED? So option A is fast action. Option B is high warm-up time. Option C, low operational voltage. And option D, long life. So here correct answer is option B, high warm-up time. Because question is that which of the following is not characteristics of LED. So high warm-up time is not characteristics of the LED. So here answer is option B. The question number 10 and last question. Which of the following materials can be used to produce infrared LED? So option A is silicon. Option B here is gallium arsenic. And option C and CDS. And option D is the PBS. So here correct answer is option B, gallium arsenic. So correct answer. Rectifiers. Rectifier is that circuit that convert AC signal to DC signal. So the following two types of rectifiers circuits can be used. First one is the half wave rectifier and second one is the full wave rectifiers. So there are two types of basically rectifiers. What is the half wave rectifiers? The process of removing one half the input signal to establish a DC level is called half wave rectifier. So this is the uh, concept about the half wave rectifier. In half wave rectification, the rectifier conduct current during positive half cycle of input AC signal only, and negative half cycle is suppressed. So in this circuit diagram of half wave rectifiers, there is the one transformer and the input AC supply to the uh, half wave rectifier with the help of step down transformer. There is a diode and load resistance. During the positive half cycle, diode conduct and the output is in the form of half wave DC. And next, in negative half cycle, diode is off. In that case, the output voltage will be zero. So a AC or sinusoidal signal convert into DC signal with the help of half wave rectifier, in which the output voltage is the DC voltage in the half cycle. AC voltage across secondary terminal AB, that is the secondary terminal of transformer AB, change its polarity after each half cycle. So during negative half cycle, terminal A is negative, so diode is reverse biased, and through the diode during positive half cycle only. In this way, current flow through the RL in one direction as shown in this uh, diagram. What is the disadvantage of half wave rectifiers? So the pulsating current in output contains AC components whose frequency equal to the supply frequency or supply input voltage. So filtering is needed. So here pulsating current in output contain AC component. So this AC content removed by the filtering method. So here needed is filtering. The AC supply delivers power during half cycle only, so output is low. What is the output frequency in half wave rectifier? So output frequency of half wave rectifier is equal to input frequency. So this means when input AC completes one cycle, rectified wave also complete one cycle. So input frequency equal to the output frequency, or there is no change in frequency between the input signal and the output signals. Next, the second application of diode as a full wave rectifiers. So what is the full wave rectifier? In full wave rectification, current flow through the load in same direction of both half cycle of input AC supply. So this can be achieved with two diodes working alternatively. So we use in this circuit diagram of a full wave rectifier, there is two diodes that is working Alternatively, for one half cycle, one diode supplies current to load, and for next half cycle, another diode works. So, in the case of center tap full wave rectifiers, this is the circuit diagram of the center tap full wave rectifier, in which the uh, secondary binding of the transformer is center taped or divided in two parts. So here we use the two diode as a for rectification purpose. So here the AC supply applied to the transformer, and then that step down transformer applied the positive cycle and negative cycle supply voltage to these two diode D1 and D2. So circuit has two diode D1 and D2 and a center tap transformer. During positive half cycle diode D1 conducts, and during negative half cycle diode D2 conduct. So it can be seen that current through load RL is in the same direction of both cycle, because there are two diode conduct. One is for the positive half cycle, and next one conduct to the during negative half cycle. So there are two diode conduct in the circuit diagram. Now next type of the full wave rectifier is the full wave bridge rectifier. So in bridge rectifier we use the four diode, uh, which is D1, D2, D3 and D4, and need for center tap PT is eliminated. Here consists of four diode instead of two diodes. In full wave bridge rectifiers, so there is the circuit diagram of working principle of the full wave bridge rectifier. During the period t equal to 0 to t by 2, in that case diode D2 and diode D3 are conductant, while during this period diode D1 and diode D4 are in the off state, or it means that the diode D2 and diode D4 in the forward biasing. So in that case, diode D2 and D3 are conductance. But in that case, in that another case, diode D1 and diode D4 in the reverse biasing, and so these two diodes D1 and D4 are in the off state. So this is the full wave bridge rectifier conduction process. Now next, during period T by 2 to T, in that case, in that during period, the diode D1 and diode D4 are conducting, and while D2 and D3 are in the off state. So here two diodes are in forward biasing, that is conducting mode, and another two diodes are in the reverse biasing condition, so they are not conducting, or that is the in the off state. In the full wave bridge rectifier, the over one full cycle, the input and output voltage will appears as shown in the figure. So VDC is the output DC voltage equal to 2 into 0.318 maximum voltage. So it will be 0.636 Bm. Bm is the maximum voltage and VDC is the output DC voltage. So what happens if we use silicon diode instead of ideal diode? In that case, the output voltage will be 0.63 volt into Vm minus 2 Vt. So output frequency of full wave rectifier is equal to double of input frequency. So for example, if the input frequency is F, so output frequency will be 2F. So output frequency in full wave rectifier is the double of the input frequency. So this means when input AC complete one cycle rectified. So what is the advantage of full wave rectifier as compared to half wave rectifiers? So here are some advantage. Need for center tap transformer is eliminated here in the full wave bridge rectifier, and peak inverse voltage is one half of that of center tap circuit. And next one advantage is the output is twice than that of center tap circuit. So output voltage is the twice that of the center tap circuit. So there are some disadvantage also. So first disadvantage is that it requires 4 diodes. This is the one disadvantage also. And next one, internal resistance voltage drop is twice than that of center tap circuit. So this is the second disadvantage of the full wave bridge rectifiers.